Okay, hello student. In our today's session, we are going to discuss some of the hypothesis testing problems that you might have. And remember, we know hypothesis testing is meant to test whether a claim made about a population or any research is valid. So, with me here, I have an example that we are going to carry out today. The hypothesis testing. This one is the single population. And in my question that I'm putting under consideration, I have an airline researcher believes that believes that the average baggage weight for each adult is 60 kgs. To test this, it draws a random sample of 50 adult passengers and weighs the baggage. He finds the sample mean to be 57.1 kg. Standard deviation is 10. Can he conclude at 5% significance level that is believed is incorrect? So that is what we need to test and see if we have the acceptance region or maybe the rejection region. So for us to be able to test this, we need to go various steps. The first steps that we need to do, we need to formulate and state whether it is a null, whether to state the null and maybe the alternate hypothesis. And remember, a null hypothesis is the claim maybe that is made by the researcher, maybe about the population, which need to be tested to confirm its validity. And in this case, our null hypothesis, let me take my highlighter. So in this case, maybe we can say our null hypothesis maybe our mu is equals to 60, because that is what the research that is what it is believed that maybe the baggage is 50. And then remember our the conclusion that has come from the sample, it states that it is not 60 but now it is 57.1 kg. 1 kg. So our alternate hypothesis in this case, which is mu is equals to 57, so is equals to 60. So is equals to 60. So we can say that we have the alternate of not equal to 60. And remember the alternate hypothesis will tell maybe is there if the null hypothesis is not true, and this alternate hypothesis maybe we state it as either maybe, we can also state at either maybe not equal, greater or less. So then the next thing that we need to test is the level of the significance. Remember here, according to the conclusion of the researcher, he believes that he concludes that 5% significant level that is incorrect. So if we ask ourselves, the confidence level here is equal, maybe the confidence level is equals to 95%, is equals to 95%. So in this case, we can say that our rejection level is only 5%. So now the next thing for us to do, it is to determine the rejection region. So, and for us to be able to determine this rejection region, we need to draw a distribution curve that is the normal distribution curve. We need to draw a normal distribution curve. A normal distribution curve, maybe we have it like this. And now, and for us to be able to determine if the distribution curve will have either a one-tailed or a two-tailed, and in this case, because we can see the sign of our null hypothesis is using the equal sign, or so we accept now our region to be either on both sides, so meaning that we shall use a two-tailed test. And a two-tailed test, maybe we can say that is a test hypothesis where maybe the region of rejection is on both sides of the sampling. So if here we have the normal distribution there, so we expect that we have said our acceptance level maybe will be 95 here, so we can distribute our rejection region, and the z-score that maybe corresponds to this, remember we can be able to get it. So in this case we are going to distribute the other rejection, or which is 5% on both sides. So in this case, when it is normally distributed, this one maybe you can say it is equivalent to 0.05. so if you distribute it from 95, here we have 0.0025, and here we have 0, maybe we have 0.0225. So the shaded region, this one we can say it is a rejection maybe rejection region. It is a rejection region, or maybe. And then we know, if for example you don't know, we can also say the corresponding z-score for these. Here we are going to have positive 1.96, and here we are going to have maybe negative 1.96. Remember, for those maybe who might not be knowing where we are getting 1.96 from, we can calculate the level of that is the, maybe for example we can calculate maybe the confidence level by taking the region on the left, that is the area under the curve under the region. So we have maybe 1 plus 95 divided maybe by 2, and in this case this one gives us maybe 1 plus 0 1.0.95 divided by 2, and in this one is equivalent to, maybe if we divide that, we shall conclude that this is equivalent to that what we have there, which is 1.996. And remember, if we are to use the z-score table to get this, you'll realize that if this one is our z on this curve here, we shall have 0.19, and then here on top we shall have maybe 0.06, and here maybe we have our confidence level, that is 0.95. that is 95. So if we take these, we add this, we get maybe, for example, we shall have 1.9 maybe added to plus 0.06, and if we add this, we are going to get maybe 1.96. So now, since we have determined that and we have decided our level of one and determined maybe our region, So we need to calculate our sample test. And from this, remember, we can conclude, because the sample used is more than 30, here we are going to use the z and not the t. If it was less than 30, we could have used the t. So now, and we know to calculate using the z test, we know that z is equals to mean minus our that is our sample mean minus our population mean, and divided by standard deviation all over the square root of our sample space, So let us continue on the next slide, so that we can be and in the same, so now we can plug. We know that in this case our sample mean is equals to 57, maybe 0.1, and then also we know that our mu is equals to 60, and then we know that our standard deviation is equals to 10, and then our n is equals to 50. So we can plug them in our formula. So we shall have 57 is 57.1 minus 60 divided by 10 divided by our the square root of 50. And if you divide this, you will realize that if you divide this, we shall have that is 57.1 minus 60. Here we have negative 2.9, and divided by, if you divide 10 divided by the square root of 50, here you get 1.414, and when you add this, you get this one is equivalent to negative 205. So now our conclusion, remember we had this in our distribution curve. Remember we had our curve like this in our distribution, and here we had negative 1.96, and here we had positive 1.96 in our rejection. So if you come and plot this to our distribution curve, you will realize negative 2.0 is far on this side of, so that is where we have negative 2. So now in that, remember the next thing it is to apply, it is to draw the conclusion. So with us plotting, you will realize that the result is found in far negative side or at the rejection region. So we can conclude that maybe we reject the null hypothesis and conclude that the average baggage weight for each adult is not 60 kgs. And that brings us to the end of this session. I was your trainer, Maurice Monene. If you found it of benefit to you, consider subscribing, like, share, and share to more students so that they can have the benefit of the knowledge also. Thank you.